Hello, we are still looking at the equilibrium of a particle, and in this question we have a small bag of mass 10 kilograms attached at point C. So this is point C, so this is where I have our bag of 10 kilograms. To the ends of two light inextensible strings AC and BC. So these are two strings AC and BC. So these are different strings because they are two inextensible strings AC and BC, meaning the tension it cannot be the same. Okay, so the other ends of the strings are attached to two fixed points. So this string here is attached at B and this string here is attached at A. Now the bag is in equilibrium with AC and BC inclined to the horizontal at 30 and 60 respectively. So it implies that this particle is in equilibrium, so forces are balanced. Forces in one direction will be equal to forces in the opposite direction. So let us put the force diagrams. We have this tension, and we also have this tension here. At an angle of 30 degrees. So if we put the horizontal here, the weight, because we have the mass is at 10 kilograms, so the weight will act downward. So that is going to be the weight. Now this angle here is 60 degrees and this one is 30 degrees. So resolving, this is T1 and this is T2. So we need to resolve this horizontally and then vertically. So this is going to be T2 sine 60 degrees. So we move to the left here. This is going to be T1. The adjacent of this angle is going to be T1 cos 30 degrees. But the adjacent of this is going to be T2 cos 60 degrees. Opposite is sine. Then the opposite of this angle, if we get the component of T1 vertically, it will be T1 sine 30 degrees. So the weight is going to be mg, which will be 10 kilograms times acceleration to gravity, that is 10 newtons. So those are the forces. So we need now to write the necessary equations. So horizontally we have T2 cos 60 and T1 cos 60. So they are opposing each other and the particles are at equilibrium, so they are equal. The two forces are equal. So the tension components will balance each other. So you have T1 cos 30 degrees equal to T2 cos 60 degrees. So T1, this is root 3 over 2, and T2 is cos 60 is a half, implying that T2 is T1 times root 3. So that is equation 1. Now solving vertically, we have T2 sine 60 and T1 sine 30. So this is T1 sine 30, that is a half, plus T2 sine 60, that is T2 root 3 over 2. We'll balance the weight, that is 10 G. This G is 9.8. So now we can substitute. Let me multiply with the 2, or let me first substitute for T2, because T2 is equal to T1 root 3. So T1 plus T2 root 3. No, let me substitute for T2. Now T2 is here. We have T1 root 3 times root 3 over 2, but now I'm going to multiply with 2 throughout. This is 20G. So T1 will be equal to 1 plus. Now when we look at this, we shall be left with 3, because root 3 times root 3 is 3, equal to 20G. So our T1 is going to be 20 over 4G, giving us 5G. And now 5G, when you press on the calculator, you get 49 newtons. That is T1. So that is done. Let us go to T2 now. By the way, this is the tension in the SC. So this is the tension in the SC. Now let us see T2. T2 is equal to T1 times root 3, meaning that we shall get root 3 times 20 over 4 times G. And when you press the calculator, that gives us 85 newtons. Finished. And this is the tension in BC, the 85 newtons. Alright, so that is how we do this number.